Hi, I'm Roger, and today we're going to talk about setting up the B83 CPAM using the SFT2841 software. I'll also be mentioning the SFT2885 software, which is used to write Logipam Logic. What we're doing here is creating the setting file ahead of time so that it can be loaded into the relay when we're on site or when the technician is on site. Once again, I'm not an affiliate or sponsored by Schneider, and what you see here is only an example. Don't use my settings, don't use my logic. What you need to do is create your own, and there again, as I always say, your mileage may vary. Okay, this is going to be somewhat of a lengthy video due to the complexity. Maybe you saw our previous video on setting up the S80. That was just for a feeder breaker. This is one of the relays that's going to be used to protect an incoming main breaker. Like and subscribe if you get any use for this, and hit that bell. You'll be notified of future content. Okay, once again, we're going to be using Logipam transfer logic. That will be part of a future video that we'll be doing here in the next couple weeks. We're not using the built-in logic that is native to the CPAM, because this particular scenario will have 5 operation modes. You'll have a full auto plus 4 semi-auto modes, and it can work between 2 different main incoming relays. It'll be a main tie-tie setup, or I should say main tie-tie main setup, so it will be somewhat complex, and there again, that'll be covered in a future video. We're also going to be using more protection settings this time. Previously on the S80, we only use the 5051 and the 50N51N as protection settings trip. He'll be using those plus 27, 59, 46, 25 for the Sync Check, and 81 for frequency. If the ANSI codes, the IEEE stuff confuses you, coming up I'll be doing a video covering that and some good ways to remember the ones that are most commonly used. Especially if you're ever going to be taking a NICET exam or you're in engineering, you're going to need to know those. I'll try to get over the most common ones and try to explain them as we get farther into this video and we're actually doing the setup. Also with this relay will be the Sync Check, as I mentioned. It's MCS05. You want to make sure you use the proper cable type. You want to make sure that if you do make an extended cable that the pinout is correct, and we'll cover that in another video. You also want to make sure when you are connecting, or the electricians that did do the wiring connected the Sync Check cable to the proper port on the back of the CPAM base unit. It could be D1 or D2, with D2 used the most common. You also need to know your breaker closing scheme. Make sure you have drawings. There's different ways that different engineers design this stuff. You'll need to know what's in the closing circuit, otherwise your Sync Check will never work. I'll also be showing how you could connect either through the SFT2885 logic in Logipam on your logic ladder for the Sync Check, or you can do it in the matrix. But don't do both, do one or the other. Otherwise you'll be having all kinds of Sync Check problems. We'll also be making use of the ACE850 TP communication module for Ethernet. This will be integrated as well into Power Monitoring Expert, which is a Schneider software product for power monitoring, power quality analysis, and I will also be covering that in future videos. Make sure you have drawings, a full set of drawings. Know how the switchgear is wired, what I/O points are used, and what's interconnected between one relay and another. Very important, or you'll never get through this and nothing will work. Been there, done that. This is fed by 2 utility sources, so therefore there'll be a main at each end. Each one will have its own settings. I'm only demonstrating an example of one for here, but the opposite end will be similar. The tie will also be involved in this with the Logipam Logic. One is what we call a dummy tie. It's normally closed. The other one is normally open, and it will have some logic built into it. And as yet, I don't know if they're using a B83 or S80 or an S84 there. I'm waiting to get the drawings on that part of it. Make sure you have your engineered settings. You need a setting file. Don't just make stuff up. You can really cause some damage. You can hurt someone or possibly even kill somebody, as well as creating all kinds of property damage. And you don't want to be the one that's liable. Make sure you have the engineered settings from a reputable engineering firm, and that you double check those settings as you enter them, after you load them, and at commissioning. The utility monitoring on this is a little bit different. We're not monitoring incoming in all 3 phases. It'll only be on VLN-A, which we'll get into when we're doing setup. What we call V prime, that is your bus voltage, and we will be having all 3 of those phases set up to monitor, and it's also part of the sync check. Make sure you have all your links to your IOs, so you know what you're doing. This again goes back to having the full set of drawings so you know everything is wired, and check one to the other. If you're looking at incoming A over here and incoming B over here, and you're looking at the drawings for each, make sure those interconnects actually are proper. I have found mistakes in the past, and it's better to find them ahead of time than when you're trying to do commissioning or final startup. In this case, we'll be having 2 MEH120 IO modules on each of the incoming relays. I'll be showing those in the setup and how we're configuring the inputs and outputs to those and the mapping of all the IO points. From there, I'll head down to the office, we'll get started and set this thing up. Okay, here in the office and getting ready to do a little setup on this B83. One of the things I did here was to put the settings into a spreadsheet. I've got one advantage here. We've got 2 mains and a smart tie, so it's a main tie main with one of the ties being a normally closed, what we call a dummy tie. Basically the settings are all the same for all 3 of these relays, with the exception of functions 46 and 81. They won't be used on the tie, but the 2 different mains have identical settings, and what's nice about that is you can create your setting file, save it for the east, and then go back, change the IP address and any changes you need to make for the west tie, and save that as the west main. Save that as west main. Then you can go back with the same file, remove the 46 and 81 settings for the tie, and then save that as a tie. It'll save you a lot of time on getting set up. Okay, what I did do here to save a little bit of time was I did pre-enter my settings in the setup, but we'll go through it here. Okay, we start out with the main screen here. When this first comes up, you'll need to check your user machine interface, or UMI. You have some choices here. Here ours is Mimic based. We do have the ACE850 TP for Ethernet. You click on this little box over here. It'll open up a window and you can put in your IP, your subnet, and your gateway if the gateway applies. And just click on OK, and that part will be done. Up here where it says SEPAM label, you want to label which relay it is. In this case, it's the east incomer. On this particular one, we have an MSA141 Analog Output module. This is going to be used to measure the frequency to a remote PLC. I believe it's a GE FANUC. So to set this up, you click on this little box, and you can pick the type of output. This one's 4 to 20, another type is 0 to 20 or 0 to 10. Then your analog value, you have a drop down where you can pick and you can scroll through here and pick all these different values you would want. We are doing frequency, minimum value of 0 and maximum value of 70. You have that set, hit OK. We have the MCS05 Sync Check module. Over here we have 2 MES120 IO modules. You have all that set, hit apply. I'll tell you, will it be changed? You want to continue? Yes. Next you go up to the tab for general characteristics. This will bring up what you want to do here. Ours, of course, is 60 Hertz. We want to use ANSI, setting group A. Usually just leave these alone here. Your demand interval, 5 minute. If you need to sync with a utility company, if you can find out when their sliding window, their block window is in intervals, you can change that value to, let's say if you have a 15-minute sliding window or 15-minute block window, you could change that. Down here with temperatures, we're going to have it in Fahrenheit. Our working language here is English. Our time synchronization mode, this is not Ethernet by default. We are going to go with Ethernet, get our time default there. Remote protection settings enabled. We don't ever use this. If it is checked, that means someone could sign online from elsewhere. Change remote protection settings. Same with remote control. You don't want that selected either, because they can sit at home if somebody got perturbed or wanted to be ornery and open your breaker remotely. There is a way to trace to see where it came from, but why go through all the headaches? Down here on control voltage, we are going to monitor the control voltage. Our rated value is 125 volt DC. The low threshold is 80% of that nominal, and the high threshold is 120% of that nominal. Okay, you're all set there. You hit apply. Next, for your Ctvt sensors, this is where we had that on a spreadsheet you saw there at the very beginning. CT rating is 5 amp, or incoming CT current is 1.2 Ka, or 1200 amps. Rated primary voltage for the PT is 8.4 kV with a secondary of 120 volt. Same with the V prime, which in this case are the bus CTs. The bus CTs are also 8.4 kV to 120. Over here, as we look at the sensors, as we're looking at the utility incoming, our voltage is only on VAN. We're not using all three phases, only one single CT there, or PT there, excuse me. On the bus, we have three PTs, which is we're calling V prime on A, B, and C. And of course, we've got CTs on A, B, and C. You're all set there. Of course, we're in ANSI. You're all set there. You hit apply. I should also mention, too, if you haven't done it already, go up here to options in your setting mode. Make sure you're using the proper setting mode. It makes a great big difference on your time curves. If you're all setting everything up on TMS and your relay is set to 10 IIS, so times are not exactly the same. I've got a little bit of a video explaining that. I'm going to do another one here in the future that goes into more detail on why that is and what exactly it means. And next is your Ctvt supervision. They have selected to have this on with a CT time delay of 150 milliseconds to block any actions. Under VTs on, the time delay of 2 seconds. And to block any action. Once you're done there, of course, you would hit apply. Next is our control logic. Switch your control on, of course. There is a box here for closing with Sync Check. We're doing it a little bit differently here by assigning an input to an output for the closing circuit, which I will get to when we're doing the ACE850 setup. They'll also have automatic transfer, but it's all going to be done with the SFT2841 software and Logipam. So we're going to leave this box unchecked. We're not going to be using the factory built-in transfer. It doesn't match what this particular facility needs. And once again, we'll be getting into that in another video. Next will be your logic IOs. There's two different ways you can do this. You can go down and select each one for what it needs to be. I do have the actual IO assignments on my spreadsheet down here in Logic. A little brief look at what all is going to be involved with that, which will be on our 2885 software. So I'm assigning everything to other use. The way you can do this is just click this button up here that says assign to other use. If you use the standard assignments, and I'm going to click on it here to show you what it does, it'll put all these values in, and you're most likely not going to be using those that way. So we want to have everything assigned to other use. I'll have to cancel that. Okay, they're back to applied to other use. Once you get done there, you need to check your inputs and outputs on what's going to be used. Use your drawings. Make sure you have a set of drawings that you can consult with. Take a look at that. For example, here, this is showing our there's an output here for a relay protection light that we need to tie in with our trips, and I'll get to that when we get to the matrix. And this shows where the sync check relay has to be. in the closing circuit, what output we're using there. Here's our CT and VT prime connections. This here's our sync check connections and what inputs and outputs we're using there and where we are monitoring. It's important you know that. And then of course you need the I/O drawing. I couldn't get the whole thing in one screen capture, but this will give you an idea of what it is. If you've got anything special you need to do, this here particular shot here is for another project. We're using an output to turn a stack light on and off according to which way the breaker is. You'll need to be able to assign your I/Os for that. Okay, getting back to our setup. From there, we're going to go up here to our protection settings. This will show you everything that's available in the B83. The ones that are grayed out aren't used right now, but the ones that are highlighted like this are ones I actually have settings in. Start with our 5051. It's our time over, current, and instantaneous. You want them on, latching, and to trip the circuit breaker. I should also mention that by latching, what you are doing is you are holding that until someone physically goes and clears the alarm and resets the relay. This is sort of an electronic ANSI86 lockout. Of course, in addition to this, we also do have an 86 electromechanical lockout relay on this installation. This is just an extra safety measure. Okay, our tripping curve here is IEEE extremely inverse, 1.6 Ka at 3-second delay. At TMS rounds it down to 2.952. And our instantaneous is 7,600 amps at 300 milliseconds. You get all done with that. You want to hit apply. And we're moving on to the 50N, 51N. And once again, units 1 and 2, latching and trip the circuit breaker. Our ground fault, time over current, IEEE extremely inverse, 1,060 amps at 3.936 seconds, which is actually 4 seconds, rounded off in TMS. And our instantaneous is definite time at 7,600 amps at 300 milliseconds. You get done with that, you would hit apply. We'll move on to, I'm going to click on this for just a second. This is something with this 50BF, and I'll be doing a video on this. The BF stands for breaker failure. What this is if a breaker fails to open under a fault condition, it will send a signal to the next current interrupting device upstream and trip it. In this particular installation, there's a couple of feeder breakers that are going to have breaker failure wired back to an input on the main. So if the feeder breaker should fail to open on an overcurrent or a ground fault, the main breaker will open. And I'll do a whole other video on that because it gets a little bit complex. Our next are ANSI 46, which is negative sequence overcurrent, or negative sequence current on balance. This will more or less tells you if you get way out of balance or if you lose a phase. We have this on to latch and to trip with definite time with a 25% of your nominal load. I'll do another video on getting into detail on negative sequence. It could be a little complex too. For ANSI 27, which is under voltage, we're having 2 of these on, but we're not latching or tripping. This is strictly going to be for the logic, for the automatic transfer. Our unit 1 is for the incoming on our VAN, and our unit 2 is for V prime or the bus. We're at 60% of nominal with a 2-second delay. Our next one we have is 59. Here we're only using unit 1, which is on the incomer on the utility side, to measure if it's more than 110% of nominal. The next one we have is 81, over frequency only, in this case, to on-latch and trip the circuit breaker if our utility incoming exceeds 63 Hertz for 200 milliseconds. And lastly, on our protection settings is our sync check. We have this on with anticipation time of 50 milliseconds. Our dBs threshold of 3%. Next at 0.1 Hertz. Next threshold at 10%. High at 105%. Low at 70%. Our no voltage operating mode is dead 1 and dead 2. Our sync is VLN sync 1 and VLN sync 2. If you happen to have this wrong, where you're looking at VLL and you're using VLN PTs and connections as they show on, where'd that go? Back to my sync check here. As they show on the sync check, if you're using the incorrect settings there, here we're using VAN on both. If you're trying to use VLL, it just flat won't work. Then you'll be scratching your head. So here our primary voltage is 7.97 kV. This is getting right down to the nitty gritty because we know what it is from utility. And our secondary voltage on our PT then would be 114 volts. This would be the same on both sides. Once you get that all set, we got better change this back to VLN. Hit apply, and we're good to go there. Okay, and while we're on the subject of the sync check, now is a good time to assign your input and your output in the matrix. I have in the past forgotten to do this before, and then when you're commissioning, it becomes a real headache as you're scratching your head trying to figure out why it doesn't work. You go up here, you click on the little matrix box. You're down here to inputs. It happens as you look at the drawing here. There's our sync check. This is in the closing circuit for the breaker. Right here we're going for output 3. So when this goes high, it needs to trigger this output. It is connected to input 104 on the MES120 MEH module. So we want to go up here to output 3 and apply. When we get into the Logipam and the SFT2885, I'll go into this a little more detail. I just wanted to make sure I got this in there and didn't forget about it. The next thing is Logipam. Here we will be using this. I will be selecting a file to put in here that was created in the SFT2885. That's the subject of a whole other series of videos which we'll get to in the future. Next is logic equations, which should be done internally. I rarely ever do this, but this is where you would enter them if you would. Next is our matrix. Here, in addition to our protection of 5051, wherever we trip a breaker, that's naturally going to trigger 01 because that's by default, that trips your breaker. We're also going to be in output 102 because that light's a remote pilot light, but we only want to light those on an actual trip. Here, like with 27 and 59, that's not intended to trip the breaker, so we will not have that energize that light, but with our high frequency, we would. This shows your logic here with your tripping. O2, output 2 blocks your closing, and of course output 3 is your closing contact. This is where we can do additional inputs and assign them to outputs, which we will get to more when I get into the Logipam. The equations can be put in here. This will show you what's been done. I should also go back here to inputs. Once we put the Logipam in, a lot of these will be highlighted and everything over here will self-fill. What you don't want to do is do something in Logipam and do it in the matrix, because you're duplicating yourself and you can very easily screw that logic up. One other little feature we have is this fault recording. I just leave this by default. Never had anything necessary else to do there. While you're there, you can also click on the mimic. If you want to edit a single line diagram, you can actually create a diagram with the edit mode. I will do a separate video on this. It's a little bit complex. But okay, we have all the settings in here. You want to save that, of course. And you'll want to print your configuration for your own record. You'd want to put some things in here. I'm not going to put in the customer's name because I need to keep it confidential. Then you put in the switchboard in the cubicle, hit OK. We'll prepare the printout. As we wait here. And you can either actually print it or you can print it to PDF. What I tend to do here is just take it to PDF. So you would hit that and just hit print. I already did this, I'm not going to do it again. But that's pretty much all there is to it. So you can take your setting, put it onto a flash drive, or if you have it on the actual laptop, take the laptop to where you need to go, plug in, and hook her up. Well, I hope you got something out of that. I know it's a little more complex than what we've done before, and if you're new to SEPAM, it can be a little bit confusing. Take your time. Make sure you go back and double check everything. Once again, save your settings as a setting file for loading into the SEPAM when you're on site or when the technician or electrician is on site, depending on who's doing it. And don't forget to make one of these. Make sure you save a configuration file as a hard copy. Keep it as a PDF. You don't necessarily have to print it out, but if somebody should lose the setting file that you created, you'll have a backup right here and you can do it all again. Not that it's fun, but you can do it all again. Next we'll be following someone out, and it might be me. I'll be doing the video on it, but we're going to do the loading and the setup on one of these relays. So what we're going to do here is a little bit of a demonstration on how to load the settings into a B83. Got the software open here. I'm already plugged into the relay. Go to connect. Go up here to where it says SEPAM. Load PC to SEPAM. You'll have to put the password in. Connect your file. Here's the one I'm selecting. Message box will come up giving you the status. It may show not responding, but it is working. It's hard to do this in a factory because there's usually a lot of noise around that you can probably hear in the background. It's also difficult to be able to use a camera in a lot of places. They don't allow it. Depending on the size of the file, it could take a little bit. This also has some Logipam Logic in it. Okay, once you're all loaded and set, always need to go back and take a look at your protection settings, make sure they're there where they're supposed to be. Helps if you click on the right tab. We're good there. We're good there. And we're good there. So here is after you're sure of that, you've double checked everything, make sure everything's online like it's supposed to be. You want to do a backup file, just click on unload. Always leave it as left. Good to go.